Good morning, everyone. This is Ginny, Assistant Professor from IT Department. Today lecture is soft computing. What is soft computing? The course outcomes are explain the biological neuron model and architecture of artificial network. Apply perception and multi-layer feed-forward neural network model. Classification problems. Analyze learning rules as urban learning. Delta rule, backpropagation algorithm, implement neural network training, testing procedure, and evaluation of network performance, apply neural networks in real world applications such as pattern recognition, prediction, data classification. The syllabus covered first unit introduction to computing and fuzzy logic, unit 2 neural networks, unit 3 genetic algorithm, unit 4 neuro fuzzy modeling, unit 4 application of soft computing. So in second unit, the next topic is unsupervised learning. First, what is unsupervised learning? Unsupervised learning is the learning method in which the neural network is trained using input data without corresponding designed output. We can also train networks where there is no teacher. This is called unsupervised networking. There is no teacher, no supervision, no predefined output labels, finds hidden patterns automatically, used mainly for clustering and grouping. Types of unsupervised learning is clustering, association. Clustering means grouping similar data together. Example, customer segmentation, students performance grouping. Algorithm means K means algorithm, hierarchical clustering, organization map. Then next type of unsupervised learning is association. Find a relationship between variables. Example, market basket analysis. Customer who buy bread also buy butter. Then dimensionality reduction. Uh, Reducing number of features while keeping important information. Example, suppose we give students marks data without telling who is good, who is average, who is weak. Then a difference between supervised and unsupervised learning. Supervised learning has labeled data, unsupervised learning has no labeled data. Supervised learning data next has a correct and exact output. Unsupervised learning, we didn't get exact output. Then in supervised learning, we can say example is classification. Unsupervised learning example is clustering. Then application of unsupervised learning is data clustering, customer segmentation, pattern recognition, image compression, anomaly detection. Then a Hochfeld network, that is correct definition is a Hochfeld network is fully connected neural network in which each neuron is connected to every other network. This is one type of network. Then energy function. We have different types of network. Discrete Hopper network, continuous Hopper network. Then unsupervised learning, Hopper network. Hopper network is a type of recurrent neural network used for associative memory. It was proposed by John Caulfield in 1982. A Caulfield network is a type of content addressable memory. Caulfield network is fully connected neural network in which each neuron is connected to every other neuron. Connection are symmetric. Wij equal to Wj. No neuron has a constant connection to itself. So it works as an auto-associative memory system. The architecture of unsupervised learning Hopfield network is single layer of neurons, fully interconnected, recurrent connections, binary output. So it's the working principle is store patterns in weight matrix. Given input, neutrons update their states laterally. Network coverage to stable area. So like this. Then types of Hopper network is a binary state continuous Hopper network. Then standard binary cofiled network. Standard binary cofiled network is recurrent. Every unit is connected to every other unit where its connecting unit are symmetrical. Then here is Cofield memory zone. We have proposed by John Cofield in 1982. In associative memory, there is unlike normal computer memory, address-based memory. Uh, Cofield memory, how Cofield memory works? Storage base. So it's a pattern base. Patterns are stored in weight matrix, weight formula, Haben learning rule, weights are symmetric, no self connection. Then energy function, Wg equal to Wg using symmetrical. The diagram shows W of AC, WAD, ABC, three inputs and values WAB, WBC, and WBD. Then Cofied memorism. Cofied memory is refers the associative memory mechanism to a cofield network. It stores a pattern in such a way that network recall complete pattern from a partly noisy input. Then it is associative memory also. Not need exact address. Network automatically recalls full stored pattern. Then in mainly for every weight connection unit I and j, Wg equal to sigma xi, all element of q, p equal to 1 xi xj. The form of Heben rule which makes the weight strength proportional to the product rates of the connector. Then memory capacity. If the network has a n neuron, it can store approximately 0.15 patterns. Then application of Hopfield memories, pattern computation, error correction, image reconstruction, optimization problem. Then next concept is Hofield network demo. This properties settles into a minimal energy state, storage capacity low, only 30% number of units. Can retrieve information even in the presence of noisy data, similar to associate memory of humans. Then unsupervised learning self-organization map. Self-organization maps it's shortly SOMS, or the data visualization technique invented by Professor Timo Honkon, also called Honkon networks, competitive learning, winner take all learning, generally reduces the dimensions of data through the use of self organization neural network. Useful for data visualization. Humans cannot visualization to high dimensional data, so this is often a useful technique to make a sense of large data. Finally, next one is basic winner take all network. So here is a two-layer network, one for input layer and another one is for output layer. Input layer, input units, output units. Each input unit is connected to each output unit. Here is we have two input layer, one input layer, three input layer, I1, I2, I3, and I3 0, 1, 0, 2, 0, 1, 2, 0, 2 is output layer. Then we have 0, 1 and 0, 2 is a output layer. Then basic algorithm. Initialize map randomly assign weights. Look for ever training example. Assign input unit values according to the values in the current example. Find the winner. That is output unit that most closely matches the input units using some distance metric. For every output units j equal to 1 to m means and input unit is j I equal to 1 to n. Find the one that minimizes, modified the weights of the winner to more closely matches the input. So input W, the values W t plus 1 equal to z of xi minus W2, where c is the small positive learning constant that usually decreases the learning proceeds. Then result of algorithm. So all the after the input we will get the output. The result is initially some output nodes will randomly be a little closer to some particular type of input. These nodes become winners and the weights move them even closer to the input. The nodes in the output become representative prototypes for examples in the input. There is no supervised training here. Given new input, the class is the output node that is the winner. Then typical is 2D feature map. The diagram shows input layer, In the output nodes from a 2D map organized by grid-like fashion, we update the weights in the neighborhood around in the winner. So input layer, we have I1, I2, I3, all three input layer. Output layers connected in 0, 1, 1, 0, 1, 2, 1, 0, 1, 3, 1, 4, 1, 5. Then 1, 2 combined as 21, 22, 23, 24, 25. Then 20. I too again connected to 31, 32, 33 up to 0, 55. Thank you.